All right, so the goal of this lesson is to introduce the idea of inference testing or hypothesis testing in statistics. So I'm going to begin with an example that builds on some content we already know and kind of develop the basic idea of this. So the question I have for us today is Mrs. Manuel a good free throw shooter? Okay, pretend I actually play basketball and that I actually am good at this. I'm going to claim that I'm an 80% free throw shooter. To prove my skills, I'll shoot 50 free throws and I make 32 of them. I wish. If Mrs. Manuel is Mrs. Manuel exaggerating about her free throw skills? So first thing is to identify some things we know from previous discussions. What is the population? What parameter are we studying? What is the sample and what is the statistic? So the population would be all Mrs. Manuel's free throw shots. The parameter would be the percent that I make, so we'll call that P for percent, or proportion, and this is the truth, the true proportion of made shots. Now, in this example, the sample would be the 50 free throws that I attempted, and the statistic would be the proportion or percent that I made. So since P represents the parameter, P hat will represent our statistic, and that would be our the 32 out of the 50, or in percentage or decimal form, 64. Now remember, I'm claiming that I am successful 80% of the time in the long run. Here I only made 64% of them. So there are two possible explanations for why I only made 32 out of 50. The one explanation is that I'm not as good as I claimed. Mrs. M is not as good as she claims. Or maybe I just had an off day. Maybe I really am 80% successful and I just had bad luck. So Mrs. M is 80% successful, just had bad luck. So how do we decide which one this is? Well, to test the claim, we start by assuming, number one, that I am an 80% success free throw shooter, and examine the likelihood that this outcome, 32 out of 50, really occurs. So we kind of assume I'm telling the truth, assume innocence until proven guilty. Now, for this activity, I'm going to just give you the details of what has happened, but we could do this in class to kind of simulate this. So the simulation, obviously I'm not going to go down to the gym and start shooting 50 throws at a time and having you watch and record, as fun as that might be. I would use a spinner. The spinner is like a little pie chart where I have it divided into two sections. A section that represents making the shot. If I'm 80% successful, that would be an 80% section of the pie. And then a section that's 20% would be me missing the shot, assuming that I am not successful. So I use this spinner as a simulation, and I spun the spinner 50 times to see what sample of made shots I would expect to get. Now, one sample of that, I did this 50 times, and I got a sample of 75%, 0.75. Now, we would do this again and again and again, and as a class, we would get a whole bunch of sample percentages of made shots from a assumed 80% free throw shooter. So another sample percent that occurred after doing this again was 0.85. Now, imagine doing this again and again and again until we have a whole bunch from our class. And when we did that, we would have a dot plot that represents that simulation. So let me change my paper here for a second instead of having to recopy my dot plot. There it is. So here is a sample dot plot. Now, if we did this as a class, you could get slightly different results, but we'd see something pretty similar. These are representing samples of 50 shots taken by an 80% shooter. So I labeled this as from 0.55, went by every 10 here to label, and recorded the dot each time that outcome occurred. So we can see that assuming I'm 80% successful, I'm getting a lot of my outcomes from this simulation falling within from 75% to 85%. I did a few times get a percentage lower than that, like significantly low or kind of high, but majority are right in here. What does each dot represent? Well, each dot represents the percent of made shots out of 50 by someone who is an 80% shooter. They're not always going to get 80% of their shots to go in. Most of the time, they'll stay pretty close to that, though. Well, what does that tell you about what happened for me when I only made 64%? Well, based on the simulation results for the whole class, how likely is it for an 80% shooter to make 64% or less when she shoots 53 free throws? Well, from this simulation, 64%, that dot right there, make that a little bigger, that was an outcome of 64% that occurred purely by chance from someone who was an 80% success for free throws. Getting that or less, how unusual is that? Answers vary from one class to another, but they kind of were close to 1%. I counted how many class dots we had, sample percentages, and how many were actually 64% or lower, and found what percent that was. So 1 out of 100 or however many there would be, it works out to be about 1%. I'll define this later, but we call that a p-value. And a p-value is the probability of an outcome or more extreme occurring purely by chance under the given assumption, in this case that I'm 80% successful. So based on on the answer to question 7, does the observed p-hat value that I got of 64% result give convincing evidence that Mrs. Manuel is exaggerating? Or is it plausible that an 80% shooter can have a performance this poor purely by chance alone? Well, because the outcome is so unusual, we look at generally anything less than 5% is very unusual. Since it is, this does give us convincing evidence that Mrs. Manuel is exaggerating. There's only about a 1% chance that an 80% shooter would make what I had happen or less, purely by chance. Therefore, I am probably not as good as I claim. This is kind of the idea of a significance test.